ഇവിടെ ബാക്കിയുള്ളവരൊക്കെ എന്ത് ചെയ്യും? 8 ആൾ മാത്രമേ ഉള്ളൂ. ഇപ്പോൾ പീരീഡിൻ്റെ ആദ്യം തന്നെ അറ്റൻഡൻസ് എടുക്കേണ്ടി വരുമല്ലോ. ഒരു മിനിറ്റ് കൂടെ വെയിറ്റ് ചെയ്യും, നോക്കട്ടെ. ഇന്നലത്തെ ലാബ് എക്സാം നിങ്ങൾ വലിയ കുഴപ്പമില്ലാതെ എഴുതിയെന്ന് തോന്നുന്നു. അത്യാവശ്യം എല്ലാവർക്കും ഒരു 50% മാർക്ക് ഉണ്ടെന്ന് തോന്നുന്നു. അതുകൊണ്ട് വലിയ കുഴപ്പമില്ല. പാസ്സാകാൻ 45-50 മതിയാവിടെ. നിങ്ങൾക്ക് എല്ലാവർക്കും 50% മുകളിലല്ലേ? എനിക്കങ്ങനെ തോന്നുന്നു. ഞാൻ അങ്ങനെ നോക്കിയപ്പോൾ കണ്ടേ. ഓക്കെ, ഇങ്ങനൊരു കാര്യം ചെയ്യാം, അറ്റൻഡൻസ് ഇട്ടിട്ട് ക്ലാസ് തുടങ്ങാം. നമ്പർ 1
റോൾ നമ്പർ 1%.
2 3 4 5 6 7
8%.
9
9%. 10%.
11
11.
12.
13
15.
16.
ഓക്കെ, അബ്സെൻ്റ് മാർക്ക് ചെയ്തത് കുറച്ച് കഴിഞ്ഞിട്ട് പോയാൽ. ഓക്കെ, നമുക്ക് ക്ലാസ് തുടങ്ങാം. Okay, so in our previous class we discussed about superconductivity and we finished the topic extended. Sorry, ഇന്നലെ അല്ല, അതിന് മുമ്പത്തെ ക്ലാസ്സിൽ. Okay, today we are going to the second part of module 5, which is photonics. Or photonic, we are studying about photonics and some of the photonic devices such as light emitting diode, solar cell, photodetectors, photodiode. Okay, what do you mean by photonics? The name itself say it is study of photons. Photonics, that means photonics, study of photon. What is photon? Photon is light. So we can say photonics is the study of light and the propagation of light. In ancient period, that means in some 1800s and 1900s, we know Thomas Alva Edison invented incandescent bulb or filament bulb. How light is produced by an incandescent bulb? You know, an electricity, a DC current is passed through a filament, specifically tungsten filament, and it heats up, and after some critical temperature or critical heat, it will glow up. So by heating, the filament will give light by glowing. Okay. But it is very very costly, and it causes many energy, so much energy loss. So after that, inventing or discovering semiconductors, or when we discovered how to manipulate semiconductor in order to produce light, we discovered one of the important electronic equipment in our today world, which is PN junction. നിങ്ങൾ ഇലക്ട്രോണിക്സ് ആൻഡ് കമ്മ്യൂണിക്കേഷൻ ബ്രാഞ്ചാണ്. സോ PN ജംഗ്ഷൻ എന്താണെന്ന് നിങ്ങൾക്ക് നന്നായിട്ട് അറിയുന്നുണ്ടാവും. ഓക്കെ, സോ ഞാൻ ഇതിനെക്കുറിച്ച് ചെറുതായിട്ടൊന്ന് പറഞ്ഞുതരാം. വാട്ട് ഈസ് എ PN ജംഗ്ഷൻ? Okay, so here before that, here I give a explanation for or definition for photonics. Photonics, it is the physical science of light waves, and or it deals with the science behind the generation, detection and manipulation of light. how light can be generated from a semiconductor junction, or how light is detected using a semiconductor junction. And one of the examples for light generation is light emitting diode. And detection, how can we detect light waves, or how can we detect a light is present in a space in a position or not? It can be done with photo detectors. Photo detectors. And third one is manipulation of light. We know that using the equipment such as laser and so many other devices, we can manipulate the properties of light using or by varying the properties of the material or the properties of electronic equipment we are using. So, and all the basic point behind our discussion is PN junction. നമ്മൾ ഇനി പഠിക്കാൻ പോകുന്നത് എന്തിനെ കുറിച്ചാണ്? We are now going to discuss about light emitting diode, LED, some type of photo detectors. That means PN junction photo detectors, pin photodiode, and solar cell. So all these semiconductor devices are based on a simple electronic equipment or simple semiconductor arrangement, which is called PN junction. Okay. So you already know what is a PN junction. And you learned about PN junction in your plus 2 classes. Okay, what do you mean by a PN junction? PN junction, it is a connection between a P-type semiconductor and an N-type semiconductor. What do you mean by a P-type semiconductor? P-type semiconductor means the majority carriers, that means the majority charge carriers in P side in such a semiconductor, such type of semiconductor is holes. Here consider that this is p-type semiconductor, and the majority charge carriers here, or the mobile ions, are holes. That means we have a lot of holes in the p side of a material. Okay, and what do you mean by an n-type semiconductor? An n-type semiconductor means the majority charge carriers in such a semiconductor will be electrons. Okay, nobody holes represent here. That means in a p-type semiconductor, the majority charge carriers are holes. Also, in n-type semiconductor, majority charge carriers are electrons. Okay, so this is the basic thing we know about p-type and n-type semiconductor. Then what happens if we connect or sandwich this p and n junction, p and n-type semiconductor together? അത് ഈ പി ആൻഡ് എൻ ജംഗ്ഷനെ സെമികണ്ടക്ടറിനെ നമ്മൾ ഒരുമിച്ച് ജംഗ്ഷൻ കണക്ട് ചെയ്ത് നോക്കുകയാണെങ്കിൽ ഇത് സംഭവിക്കും. This is what happens. These electrons here will travel through this junction and reaches the p-type p side of this pn junction. When we connect a p-type semiconductor and n-type semiconductor, electrons here will travel to this side because this is attracted by the positive holes. So here the electrons will reach the p side and carrier recombination happens. What do you mean by carrier recombination? Carrier recombination means it is the recombination between charge carriers. Who is the charge carriers here? In inside, the charge carrier is electrons, and in p side the charge carrier is holes. So when we connect the p-type semiconductor and n-type semiconductor in a p-n junction, these electrons will move towards this p side, and electrons and holes recombine here, or we can say carrier recombination takes place. So after some time, a lot of electrons will travel from n type to p type p side, and some carrier recombination takes place. After that, here in this part, the remaining thing is ഈ ഇലക്ട്രോൺ ഇവിടെ നിന്ന് പോയി കഴിഞ്ഞാൽ ബാക്കി ഇവിടെ എന്താ ഉണ്ടാവുക? Here we have positive ions is remained back, or pentavalent atoms. How n-type semiconductor is made? From silicon, from an intrinsic semiconductor from such a silicon, uh, n-type semiconductor is made by doping pentavalent atoms with silicon. So in an n-type semiconductor, when electrons are some of the electrons are passed through this junction to p side, the remaining will be positively charged immobile, and and this is important. Immobile immobile atoms or lattices, positively charged immobile pentavalent atoms are remained here. Similarly, the electrons which is reached from inside, and here the carrier recombination takes place, and the remaining here will be trivalent, negatively charged trivalent lattices or trivalent atoms. So എന്താണ് ഇവിടെ സംഭവിക്കുന്നത്? നമ്മളൊരു പി ടൈപ്പ് സെമികണ്ടക്ടറും എൻ ടൈപ്പ് സെമികണ്ടക്ടറും കണക്ട് ചെയ്യുന്ന സമയത്ത് the electrons will enter into this p side of this pn junction and carrier recombination takes place. So after carrier recombination takes place, the remaining thing in this region is, in n side we have a lot of positively charged immobile pentavalent atoms or ions. Here we have negatively charged immobile trivalent ions. So there will be a collection or accumulation of positive charge here which is immobile. ഈ പോസിറ്റീവ് ചാർജിന് മൂവ് ചെയ്യാൻ പറ്റില്ല ബിക്കോസ് ദേ ആർ ലാറ്റൈസ് അയോൺസ്, ആറ്റത്തിന്റെ ഭാഗമാണ്, ഇലക്ട്രോണിനെ പോലെ അല്ല. ദേ ആർ lattice ions, so they are immobile. Similarly, here negatively charged trivalent atoms are also immobile. So between this accumulation of positive and negative charges, there will be a development of electric field between these charges. ഒരു ഇലക്ട്രിക് ഫീൽഡ് ഡെവലപ്പ് ചെയ്യും. And this region in which an electric field is developed between this accumulation of immobile atoms with opposite polarity is called depletion region. Depletion region. Depletion region, or an electric field is formed in this region. That means in the pn junction a depletion region is formed, or an electric field is formed, or we can say corresponding to an electric field a potential is formed, or we can call that potential related to this electric field developed here as barrier potential. So നിങ്ങൾ ഈ ടേംസ് ഒക്കെ ഒരുപാട് കേട്ടിട്ടുണ്ടാകും. സോ അറിയാവുന്ന കാര്യമാണെങ്കിൽ കുഴപ്പമില്ല, ജസ്റ്റ് ഒന്നും കൂടി പറഞ്ഞു പോകാം. ദിസ് പൊട്ടൻഷ്യൽ ഈസ് കോൾഡ് ബാരിയർ പൊട്ടൻഷ്യൽ. സിൻസ് എ ബാരിയർ പൊട്ടൻഷ്യൽ ഈസ് ഡെവലപ്ഡ് ഹിയർ, നൗ ദ മെജോറിറ്റി കാരിയേഴ്സ് ഇൻ എൻ സൈഡ് cannot pass through or cannot pass through or cover this barrier potential to reach the p side. ഇവിടെ ഒരു ബാരിയർ പൊട്ടൻഷ്യൽ ക്രിയേറ്റ് ചെയ്യപ്പെട്ടത് കൊണ്ട് തന്നെ എന്ത് സംഭവിക്കും? ദ മെജോറിറ്റി കാരിയേഴ്സ് ഇൻ എൻ സൈഡ്, അതായത് ഇലക്ട്രോൺസിന് പിന്നെ അങ്ങോട്ട് ഈ പി സൈഡിലേക്ക് പോകാനോ അല്ലെങ്കിൽ ഹോൾസിന് ഈ എൻ സൈഡിലേക്ക് പോകാനോ പറ്റില്ല. ബിക്കോസ് ദർ ഇസ് എ ബാരിയർ പൊട്ടൻഷ്യൽ ബിറ്റ്വീൻ ദിസ് പി ആൻഡ് എൻ, or there is in at pn junction a depletion region is formed. So in order to cover this barrier potential, or in order to move into p side, these electrons or the majority carriers in n side should have energy greater than the barrier potential. So barrier potential നെക്കാളും എനർജി കൂടുതലുള്ള ഇലക്ട്രോൺ എന്ത് പറ്റുള്ളൂ? പി സൈഡിലേക്ക് പോകാൻ പറ്റുള്ളൂ. സിമിലർ ഇൻ കേസ് ഓഫ് holes also, the holes which have higher energy than barrier potential or depletion potential in depletion region can only move towards this side. So this is how a depletion region is formed in a p-n junction. Okay, so remember these terms. What do you mean by majority carriers? Majority carriers or majority charge carriers, that means in n side it is electrons. That means electrons are charge carrying particles in n side, and p side they are holes. So that you mean by majority carriers. And next term is one of the important term is minority carriers. What do you mean by minority carriers? This majority and minority is dependent on how much number they are present. That means inside a large number of electrons are present, or large number of negatively charged carriers are present. So we say that in inside majority carriers are electron, and if some holes are present, that means some tiny amount of holes are present, then we can say in inside holes are minority carriers. Similarly, when taking p sides, holes are majority carriers and electrons are minority carriers in p side. Okay, so these terms are important: majority carriers, minority carriers, carrier recombination, immobile atom, depletion region, barrier potential. So ഈ ടേംസ് നിങ്ങളുടെ ഉത്തരത്തിലൊക്കെ യൂസ് ചെയ്യുമ്പം it means you know something about semiconductor physics. Okay, now what happens if this pn junction is forward biased, or what happens if this pn junction is connected to a battery? That means we have a pn junction here, This is P side, this is N side. We have a lot of holes here and electrons here. Consider that this PN junction is forward biased. What do you mean by forward biasing? Forward biased. Forward biasing means connecting the P side of a PN junction into positive terminal of a cell or a battery, or, and connecting the negative terminal to the N side. This you mean by forward biasing a PN junction. So what happens when we forward bias a PN junction? Then we know there is a depletion region here, or a barrier potential will be developed here. So when we are forward biasing a PN junction, we are actually applying an electric field which is opposite in direction, opposite in direction of electric field which is formed in barrier potential or depletion region. We already said that there will be an electric field will be developed in this barrier potential. When forward biasing a PN junction diode, we are actually applying an electric field opposite in direction to this electric field which is developed in barrier potential. So actually we are making this barrier depletion region very small. അതായത് ഡിപ്ലീഷൻ റീജിയനിൽ ഒരു ഇലക്ട്രിക് ഫീൽഡ് ഉണ്ടാവും, അതിന് ഓപ്പോസിറ്റ് ഡയറക്ഷനുള്ള ഇലക്ട്രിക് ഫീൽഡ് നമ്മൾ ആക്ച്വലി എന്ത് ചെയ്യുകയാണ്, കൊടുക്കുകയാണ് വെൻ ഫോർവേഡ് ബയാസിങ് എ പി എൻ ജംഗ്ഷൻ ഡയോഡ്. Or what happens here is this positive terminal is connected to holes. So there will be holes will be moving from this side to this side, and from negative terminal electrons are moving from this wire or connection to this side. So the density of holes and density of electrons both will on the both sides will increase. This will squeeze down, or this will narrow down our barrier potential. And after a limit, that means if the potential offered by this cell or this battery is greater than the barrier potential of this depletion region, then our electrons will cover up, or electrons will penetrate through this barrier potential and reach the P side. So we can say this circuit get completed, or we can say a current will be flown through this PN junction diode. If the potential offered by this cell or this power source is greater than the barrier potential, that means electrons, the majority carriers in the N side, now attained an energy which is greater than the barrier potential. Now they are able to move across this barrier potential or depletion region and to reach the P side, and it completes the circuit, and we can say a current will be flown through this circuit. And if, for example, if we draw the IV characteristics of a PN junction diode in forward bias case, it will look like this. That means up to some voltage, നമ്മൾ എന്ത് ചെയ്യുന്നു, 0 മുതൽ വോൾട്ടേജ് അപ്ലൈ ചെയ്യാൻ തുടങ്ങുന്നു. So after apply from 0 to some VB, what happens? A tiny amount of current only will be flow through circuit, because up to that point the barrier potential or the potential difference offered by this cell is less than the barrier potential up to this point. So up to this point these electrons are not able to pass through this barrier potential, but after applying the voltage which is greater, after applying the potential which is greater than the barrier potential, then the electrons are able to move across the junction and a current will be formed in the circuit, and it will increase. It is shown by this IV characteristics of a PN junction diode. And when studying a PN junction, when studying the forward characteristics or forward biased PN junction diode, we want to talk about LED. നമ്മൾ എന്തായാലും സംസാരിച്ചിരിക്കേണ്ട ഒരു ടോപ്പിക്കാണ് LED or light emitting diode. This is what happens in an LED. When we apply a potential which is higher than the barrier potential, then what happens? In an LED, this electron will attain the energy greater than, or which makes them to move through this barrier potential. So after reaching P side, what happens? In an LED, after reaching P side, we know that there are many holes in P side. So these electrons will recombine with these holes, and light energy is produced. എന്ത് പറ്റും? LED കേസിൽ നമ്മളൊരു പൊട്ടൻഷ്യൽ കൊടുക്കുമ്പോൾ N സൈഡിലെ മെജോറിറ്റി കാരിയേഴ്സ് P സൈഡിലെത്തും, and there are so many holes in P side, and carrier recombination happens, and the extra energy which is delivered from this carrier recombination will be produced as light. This is happens in an LED. Okay. Then what happens if a PN junction diode is reverse bias? Consider we have a PN junction diode. PN junction diode. What do you mean by reverse biasing a PN junction diode? It means that connecting the P side of the PN junction into negative terminal and N side of the PN junction into positive terminal. Now you can say that we are applying an electric field opposite in the same in the same direction of electric field in the barrier potential. So in case of forward bias, we said that by forward biasing a PN junction diode, we are applying an electric field which is opposite in direction to electric field in barrier potential. Or we can say this electric field offered by this cell or the power source or whatever it be, it is squeezing down or it is narrowing down this depletion region, or it is opposing the electric field in depletion region. But when reverse biasing a PN junction diode, actually our cell or our battery is applying an electric field which is in direction of the electric field in depletion region, or we can say here the reverse biasing of a PN junction result in the widening of depletion region, or now the depletion region become more wide. Why? Because we know that in P side there will be lot of holes, in N side there will be lot of electron. So when reverse biasing, we know that holes here will be attracted to negative terminal. We know holes are positively charged and negative terminal is have a negative polarity, so these holes will are attracted to this negative terminal. These electrons which is majority carriers in N side will attract to the positive terminal. So what happens? So the carriers, charge carriers are attracted to two terminals. Now the depletion region become very wide. This is what happens in a reverse biasing of a PN junction diode. And when talking about the reverse biasing of a PN junction diode, we must talk about photodetectors. Photodetectors. So before that, we can say that in depletion region, we can talk about now talk about depletion region. What happens in a depletion region? In depletion region, there are thermally generated electron hole pairs. We know in room temperature we have some heat energy. So due to this heat energy, in this depletion region we have thermally generated electron hole pair, and this electron hole pair will get attracted to the P side and side based on their polarity, and a small current will be present in the circuit. The depletion region thermally generated electron and hole pair ഉണ്ടാവും, and based on their polarity they are attracted to P side and N side, and this minority carriers get moving through the circuit will provide or will produce a current which is called reverse current, or some minority current. So when applying a light or incidenting a light with on the PN junction which is reversed bias, അല്ലെങ്കിൽ reverse bias ചെയ്തിരിക്കുന്ന ഒരു PN ജംഗ്ഷനിൽ നമ്മൾ ലൈറ്റ് അപ്ലൈ ചെയ്യുകയാണ്, എന്ത് പറ്റും? Then more electron hole pairs are generated in this depletion region that will contribute the flow of current through this circuit. Or that means a reverse biased PN junction can be used as a photo detector. Okay. So this is what you know about. ഞാൻ കുറച്ച് ചെറിയ കാര്യങ്ങളെ പറഞ്ഞുള്ളൂ. What you mean by a PN junction, what you mean by majority and minority carriers, what happens when two types of two semiconductors, that means p type and n type semiconductor is connected, or when PN junction diode is formed, with that a depletion region is also formed. So when forward biasing a PN junction, we know that after applying a potential which is greater than the barrier potential, the majority carriers in both sides, or specifically speaking, the majority carriers electrons in the N side get the energy to pass over this barrier potential, and the current will flow along the circuit. Similarly, in case of reverse biased condition, the depletion region become wide because the electrons are attracted to the positive terminal and also attracted to the negative terminal. So our depletion region become wide, and Now, more thermally generated or more optically generated electron hole pairs are created, and a small current will pass through the circuit, or we can measure a current across the semiconductor. That current is called minority current, and the maximum value of that current is minority saturation current. Sorry, reverse saturation current. And so, by measuring that current, we can say, we can predict whether a light is incident on the material, or how much electron hole pairs are generated in depletion region. Okay. So ഇതാണ് നമ്മുടെ പി എൻ ജംഗ്ഷനെ കുറിച്ച് പഠിച്ചത്. Now we are going to our main topic. സോ നിങ്ങളുടെ എക്സാമിന് പി എൻ ജംഗ്ഷൻ എന്താണെന്നൊന്നും ചോദിക്കില്ല, ഇത് മനസ്സിലാവാൻ വേണ്ടിയാണ് പറഞ്ഞത്. Now we are going to study about LED. LED is a PN junction diode that gives off visible light when forward biased. When forward biasing a PN junction diode, what happens? Forward biasing a PN junction diode, more electrons from the negative terminal will reach the N side of the semiconductor or PN junction. Also, more holes will be reached the P side of semiconductor. When the potential applied by this cell is greater than the barrier potential of this cell is greater than the barrier potential of this PN junction, VB. Or in other words, we can say that when the energy of these electrons in here or inside is able, or it is greater than the barrier potential, or it is able to pass the PN junction, now what happens? These electrons will pass through this, pass to this p side. Or look here, what happens here? Here an electron and hole gets recombined, and this extra energy of recombination, like electron hole pair energy in the recombination energy, so this extra energy of recombination will get emitted at light. So thousands or millions of these electron hole pairs get recombined in some in a small time. So what happens? We get a big amount of light, and that is the working principle of a light emitting diode. Okay, again, what is an LED? LED is a light emitting diode. That means it is a PN junction diode which is forward biased. What happens when a PN junction diode is forward biased? If the potential offered by the cell is greater than the barrier potential, carrier recombination happens. So when carrier recombination happens, the extra energy is given off by light. So it is given by, so this is how light is emitted by a LED or light emitting diode. Okay. And the frequency of the light emitting diode, or how can you predict the color of a light emitting diode? This color of light emitting diode can be uh, defined as, we know that energy gap, or energy E, is given by h mu according to quantum mechanics, or the frequency of the color emitted by an LED is given by Eg by h. That means for a semiconductor, that means നമ്മൾ semi PN junction semiconductor കേസിൽ, if it is silicon, what happens? There will be a band gap. That means there will be a band gap between conduction band and valence band. So electrons in valence band require an energy to reach the conduction band to recombine with holes. When forward biasing a light emitting diode, we are actually applying this energy, this band gap energy, Eg. So receiving this much of energy, this electron hole recombination takes place, and then extra energy is given off by, or this energy is given off by light. And let the frequency of that light be mu, so the energy can be represented as h mu. So the frequency of light which is emitted by an LED can be given in the terms of band gap energy of the semiconductor, which is used to make that LED. And h, we know what is h. H is the Planck's constant. Okay, now we are moving to photodetectors. What do you mean by photodetectors? The function of the photodetector is to detect the optical signal and are based on semiconductor PN junction devices. What is the function of a photodetector? The name itself say it is a photodetector. What is photo? It is photo, or photon means light. So photodetectors, we can say they are light detectors, or it indicate that light is present or absent in a certain region, or it is a sensor which gives us the information about the light which is present in a region. എത്രത്തോളം ലൈറ്റ് ഒരു റീജിയനിൽ പ്രസന്റ് ആയിരിക്കും എന്നുള്ള ഇൻഫർമേഷൻ നമുക്ക് തരുന്ന ഇലക്ട്രോണിക് എക്യുപ്മെന്റ് ആണ് ഫോട്ടോ ഡിറ്റക്ടേഴ്സ്. So, what is the working principle of a photodetector? Photodetectors are so many types. We will discuss about that. Now, what is the basic working principle behind photodetectors? When a PN junction diode is connected in reverse bias, it is important. When a PN junction diode is connected in reverse bias, a large depletion layer is created. We know why a large depletion layer is created when a PN junction diode is reverse biased. So, when light energy greater than the band gap energy falls on a depletion layer, what happens? The electrons will get excited to conduction band, leaving a hole in the valence band. These electron hole pairs are produced and hence the electric current. So this is what happens. So here we know that when reverse biasing a PN junction diode, a large depletion layer is formed. So due to this large depletion layer is formed, there will when light is incident on this depletion layer, by absorbing the energy of that light, electron hole pairs are formed. എന്ത് പറ്റും? ലൈറ്റ് ഡിപ്ലേഷൻ റീജിയനിൽ ഫാൾ ചെയ്യുമ്പോൾ എന്ത് സംഭവിക്കും? This the electrons and holes in this, or the electrons in the depletion region will absorb this energy, and electron will get excited from valence band to conduction band, or we can say electron hole pairs are created. So this electron hole pairs will contribute to the current flowing through this circuit. Okay, this is how. So by measuring this current, we can predict how much light is present on this depletion region, or how much light is incident on this depletion region. എന്താണ് സംഭവം? ഡിപ്ലീഷൻ റീജിയനിൽ ലൈറ്റ് വീഴുന്ന സമയത്ത് സംഭവിക്കും? ഇലക്ട്രോൺ ഹോൾ പേഴ്സ് ഉണ്ടാവും. ഇലക്ട്രോൺ ഹോൾ പേഴ്സ് ഉണ്ടായി കഴിഞ്ഞാൽ, based on polarity, it gets attracted to p-type and n-type semiconductor, and it gives off the current in the circuit. So by measuring that current, we can predict how much light is present in this region, or whether light is present or absent in a region. Okay, so photodetectors can be classified into two types. First one is photodiode. It's really not a classification. We are only studying about two types of photodetectors. First one is a PN junction photodiode. What do you mean by PN junction photodiode? It is a silicon or germanium PN junction working under reverse biased condition. And the reverse current increases when the light falls on junction. ഇത് തന്നെയാണ് പറഞ്ഞുകൊണ്ടിരിക്കുന്നത് സംഭവിക്കും. A photodiode works on a reverse bias. Actually, it is a reverse biased PN junction. So when light falls on a photodiode, what happens? Electron hole pairs are created. A current will travel along. Current will move along. A current is created in the circuit. So by measuring this current, we can measure the intensity of light, or we can measure how much light is incident on this PN junction or this material. And also we know that when reverse bias, when we reverse bias a PN junction diode, or if we apply some reverse voltage, or a tiny reverse voltage in a PN junction diode, say a small current will be flow through this diode. And we are talking this when no light is present, അതായത് ലൈറ്റ് ഒന്നും ഇൻസിഡന്റ് ചെയ്യുന്നതിന് മുമ്പുള്ള കാര്യമാണ് പറയുന്നത്. And this current is produced due to thermally generated minority carriers. So we are talking about thermally generated minority carriers. When light is absent, and if we apply some tiny amount of reverse voltage, a small current will be passed through this reverse biased PN junction or this circuit. And this current flowing through this reverse biased photodiode when no light is incident on this junction is called dark current. Okay, what do you mean by dark current? എന്താണ് dark current എന്ന് പറഞ്ഞാൽ? ഈ ലൈറ്റ് ഒക്കെ ഇൻസിഡന്റ് ചെയ്യുന്നതിന് മുമ്പ്, before incidenting this light, that means if light is absent due to thermal excitation, or some thermally excited electron hole pairs will be created in the semiconductor. Mainly we are conducting this experiment mainly in the room temperature ലായിരിക്കും നമ്മൾ ഇതൊക്കെ ഒബ്സർവ് ചെയ്യുന്നത്. So in room temperature is 300 Kelvin. So there will be thermally generated electron hole pairs in depletion region, and it will contribute to current, or it will produce a tiny amount of current in this circuit. And that current, without incidenting a light, is called dark current. Light incident ചെയ്യാതെ ഉണ്ടാകുന്ന കറണ്ടിന്റെ പേരാണ് എന്ത്? Dark current. Or we can say that according to Ohm's law, dark resistance equal to VR by ID. What is VR? VR is the reverse voltage we are applied in the circuit, and ID is the dark current, or how much current is developed in the circuit when no light is present in the depletion region of a PN junction photodiode. Next one is pin photodiode. So what is a pin photodiode? Only difference between a pin photodiode and a normal PN junction photodiode is there is a intrinsic region. സാധാരണഗതിയിൽ ഒരു PN junction എന്ന് പറഞ്ഞാൽ എന്താണ്? What do you mean by PN junction? That means we have normally a PN junction means it is a junction between a p-type semiconductor and n-type semiconductor. In pin photodiode, it means we have a p-type semiconductor, and here we have a n-type semiconductor. Between this p-type and n-type semiconductor, there will be a region which is called intrinsic region. Why? You heard about intrinsic semiconductor. Intrinsic semiconductor എന്ന് പറഞ്ഞാൽ that is not doped. It is a pure semiconductor. So between this p side and n side, there will be an intrinsic semiconductor, or there will be an intrinsic region is built between this p and n side of a PN junction. Such type of junctions or such types of photodiode are called pin. ഈ പേര് തന്നെ നോക്കുക, pin photodiode. Pin photodiode. So what is the advantage of a pin photodiode? Pin photodiode advantage എന്താണ്? Because here we know that after connecting this P and N junction with the intrinsic semiconductor, there will be negative immobile atoms here formed here, and positive pentavalent immobile atoms are created here. So there will be an electric field from this direction. So here electric field are developed in a large direction, or we can say the depletion region become wide. Depletion region become wide. Pin photodiode ഉപകാരം എന്താണ്? ഈ ഇൻട്രിൻസിക് റീജിയൻ നമ്മൾ ഇടയ്ക്ക് കൊണ്ടുവച്ചതുകൊണ്ട് തന്നെ നമ്മുടെ ഡിപ്ലീഷൻ റീജിയന്റെ അല്ലെങ്കിൽ ബാരിയർ പൊട്ടൻഷ്യൽ ഡെവലപ്പ് ചെയ്യുന്ന റീജിയന്റെ വലുപ്പം കൂടി, ഇറ്റ് ബിക്കം വൈഡ്. So that become wide means what is the advantage? So more light can be incident on this material. സോ നമ്മൾ ലൈറ്റ് സെൻസ് ചെയ്യാനാണെങ്കിൽ എക്യുപ്മെന്റ് വെക്കുന്നെങ്കിൽ എന്താ, വലിയൊരു ഡിപ്ലീഷൻ റീജിയൻ ആണ് പിൻ ഫോട്ടോ ഡയോഡ് വെൻ കമ്പയർഡ് ടു നോർമൽ പി എൻ ജംഗ്ഷൻ ഡയോഡ്. സോ എ ലോട്ട് മോർ ലൈറ്റ് or lot of photons will get incident on this intrinsic in this depletion region. So what happens? So there will be a current due to electron hole. So more electron hole pairs are formed. So that means more current will be flown through this circuit. So what is a pin photodiode? Pin photodiode എന്ന് പറഞ്ഞാൽ there will be an intrinsic region between P and N type semiconductor. So due to the insertion of this intrinsic region, what happens? The width of depletion region increase drastically. So what is the advantage of or use of a wide depletion region? So if we have a wide depletion region, that means more photons will get incident on this depletion region. That means more electron hole pairs are formed in this depletion region, or we can sense a tiny amount of light using pin photodiode. The ചെറിയൊരു amount of light ഉണ്ടെങ്കിൽ തന്നെ എന്താണ്, ഇത് വലിയൊരു ഡിപ്ലീഷൻ റീജിയൻ ആണ്. ദിസ് ഇസ് എ ബിഗ് ഡിപ്ലീഷൻ റീജിയൻ. സോ ഇറ്റ് വിൽ ഗെറ്റ് അബ്സോർബ് and it will give corresponding current. So we can measure or sense tiny amount of light using pin photodiode when compared to normal PN junction photodiode. ഓക്കെ, സോ 9:30 സോ അറ്റൻഡൻസ് മാർക്ക് ചെയ്തതിൻ്റെ പറയാം. 2, 4, 5, 6, 7, 11 അബ്സെന്റ് മാർക്ക് ചെയ്ത്. ഹലോ,
7 ഉണ്ട്.
7.
സാർ 8 പ്രസന്റ് ആണ്.
ശരി, ഓക്കെ. 8:50 ക്ലാസ് വെച്ച് 8:50 തന്നെ എല്ലാവരും ജോയിൻ ചെയ്യണം. ഈ 10-15 മിനിറ്റ് ജോയിൻ ചെയ്തിട്ട് എന്താ കാര്യം? ഓക്കെ, അപ്പം ഞാൻ അബ്സെന്റ് മാർക്ക് ചെയ്തത് 4, 5, 6 and 11. ഓക്കെ, താങ്ക് യു.